Hopefully, there we go. Okay. So we're going to go over just kind of, now that we've seen where hyperbolas come from and everything, and like kind of done some investigating of what affects their equations and graphs and whatnot, we're going to get the kind of the more plug and chug rote equations for it that we can use now that we've seen kind of the background to them. So with that, equations of hyperbolas, go ahead and grab your notes. Today's notes and things should be fairly short. And then today's homework assignment is just going to be one IXL in addition to finishing up with the Desmos thing if you didn't finish it up. So that's geometry. Here we go. .3 hyperbolas. Okay, so kind of like ellipses, where we had different equations for a horizontal versus a vertical transverse axis, or horizontal versus vertical orientation to it. We're going to have this, it's the same kind of idea here with hyperbolas. So as we saw in our investigation thing, we had hyperbolas that looked like this, and we had hyperbolas that looked like this. Okay, and so this line between the vertices is called the transverse axis. And the transverse axis acts as a line of symmetry for the hyperbola. And so our equations are different, as you guys saw in that investigation, for a horizontal versus a vertical transverse axis. So for if we're just kind of putting down, I'll make a chart here, the equation, and then our headings, we're going to have a horizontal transverse axis. I'm just going to abbreviate it as TA. And for a vertical transverse axis. Okay. So the general equation for it, for a horizontal transverse axis, is x minus h squared over a squared minus y minus k squared over b squared equals 1. And I believe we saw that, and so that correlates with this picture. Didn't do that very well. This would be our horizontal transverse axis. This would be the vertical one. So really these two should be switched, but oh well. We know what vertical and horizontal mean, so hopefully we won't let them mess us up. But there we go. So that's the equation given a horizontal one. For vertical, y comes first. So that's an easy way to remember it too. If x comes first, or is, the one that's positive, not being subtracted, then that means you've got a horizontal transverse axis, and the x-axis is horizontal, so those should be easily linked in our brains there. For a vertical transverse axis, y comes first and is positive. So y minus k squared over a squared, and the y-axis is vertical, so that should be kind of linked in our brains. And then x minus h squared over b squared equals 1. All right, so we have the equation. We have the vertices. So for the horizontal one, it's h plus or minus a, k. And then for vertical, it's h, k plus or minus a. The center is HK, just like it has been this whole time for all of our conics. Then we have the foci. H plus or minus C K, and we'll talk about C in a moment. And then HK plus or minus C. The transverse axis. So the axis itself is y equals k. The length of the transverse axis is 2a. And then for this one, it would be x equals h, and the length is still 2a. The equations of the asymptotes. For this one, we have y minus k equals plus or minus b over a times x minus h. That's what it is if you're using point slope form, which tends to be easier to do, particularly if you're not given a graph of the hyperbola. But you know something like the center and you know what a and b are. If you're just given the equation, you can find the asymptotes pretty easily by using this format here. And I believe we also saw that in our investigation activity. But a lot of people said they preferred the slope-intercept way, which was interesting. And I'm thinking the reason that we preferred the slope-intercept way was probably because we were able to see the graph and like pull points and stuff like that from the asymptote. But if we can't pull points, that way of doing it becomes a little bit more difficult. So anyway, that's the equations of the asymptotes that we'd be working with there. And this is almost the same thing for the other way. It's just A and B are flipped. Okay. And then what the graph would look like. If the transverse axis is horizontal, it might look something like this. If the transverse axis is vertical, it might look something like this. But that's just a rough sketch. Okay, so that is all the information that we want to be able to pull from the equation or tell by just looking at the equation, or even tell from the graph, really. We want to be able to do a lot of different things with these. We want to be able to take an equation and pull this information from it so that we can graph it. We want to be able to take some of this information and construct the equation and or construct the graph. So yeah, pretty much just like we've been doing with all of our other ellipses, circles, and parabolas over the past week or two. Okay, so now that we have all of these things, let's do a couple of examples here and we will be done. We're going to continue on with hyperbolas tomorrow, so there will be more to come here. So we're just going to do a couple of examples, pretty much given the equation, pulling stuff from the equation, or given the graph, pulling stuff from the graph. Okay. And I don't think there's quite enough room on that sheet, so we'll do an example on this one. First example, we're going to take the equation We'll go y squared over 16 minus x squared over 4 equals 1. And we want to identify center, vertices, foci, and the asymptotes. Just from the equation. Oh, and I guess also the length. We'll do length of transverse axis as well. Since that's another thing that we'll want to have. And it's fairly easy to point out. Okay. So first thing that we might notice is that y comes first. So that means that our transverse axis is going to be vertical. We also might notice that our center h and k are both 0 here. So the first thing that you kind of want to do here is find h, k, a, and b. Oh, the other thing that I should have mentioned, sorry about that. If we look back at our other sheet, notice that we have foci are h plus or minus c, k. I said we were going to talk about c, and we did not talk about c. So for hyperbolas, it more has the relationship that you would expect. For the foci, a squared plus b squared equals c squared. So with ellipses, we knew it was a squared minus b squared equals c squared, and it was, didn't sound really, or it sounded kind of like the Pythagorean theorem, but not really. This one goes by the a squared plus b squared equals c squared, the way that we would think of it. So that's also an important relationship here. So we want to have that written down somewhere, and make sure that we make that distinction for hyperbolas versus ellipses. Okay, so now that we have that, we want to find h, k, a, b, and c. So that's kind of our first step out of our equation. So looking at this, we know that h is 0 because it's x without anything plus or minus up here. And then k is also 0. What's a going to be? Looking at this equation, what's a? All right, we got 1 vote for 2. Anyone else think we got some votes for 4? Yeah, so a and b will be 2 and 4 because the square root of 16 is 4 and the square root of 4 is 2. It's just that a comes first. So a is the square root of 16, which is 4. B is the square root of 4, which is 2. Yeah, no, a is not always under x. It's a is with whichever one comes first. Okay, so once we have that, then we can identify all of these other pieces. So things like the vertices, the center, the foci. So take a moment here real quick, since we've got all of our equations and things like that, go ahead and find the vertices, the center, the foci. We do have to find c, I guess, real quick as well, but a squared plus b squared equals c squared, so 16 plus 4 equals c squared. So c is the square root of 20. When you think you've got the center, vertices, foci, asymptotes, length of transverse axis, put got it in the chat. All right, if you got the center at 0, 0, the vertices at 0, 4, and 0, -4, the foci at 0, 2 root 5, and 0, -2 root 5, you're on the right track here. And then asymptotes of y equals 2x and y equals -2x. And the length of the transverse axis would be 2 times a, which is 2 times 4, which is 8. Any questions with any of these? Any that we're not sure how we find them? Any that we want to see expanded a bit? Is A always either the first one or the bigger value? That's where this is different than ellipses. Good question. That is an important distinction. On an ellipse, A is always the bigger value. But on a hyperbola, it's always the one underneath the positive variable. So like seeing how this is a y minus x here, a is going to be under the y because the x value is the one being subtracted. So it's always whichever one, pretty much whichever one comes first, although you could see it if someone was trying to kind of trick you. You could see the equation written as like negative x squared over 4 plus y squared over 16 equals 1. And this is still the same equation as this, but this is the a value because this variable is negative. So it's whichever variable is not being subtracted, the thing under that is going to be your a squared value. Yeah, good question, because that is an important distinction as a difference between ellipse equations and hyperbola equations. Then if we were going to go and graph this thing, we could use a graphing calculator or something like that. But we could also just use the information we have here. So let's use the information that we have, especially since this one's nice and easy to graph at our center of 0, 0 by hand. So the vertices are at 0, 4 and 0, negative 4. I wouldn't worry as much about graphing the foci at the moment if you're just trying to graph the thing to start with, but I would graph the asymptote so that you know kind of where this thing's going. So the asymptotes y equals 2x. And y equals negative 2x. So we know these are asymptotes. So then our actual graph of the hyperbola is going to look something like this. And then the foci will be out here somewhere. But we don't worry as much about graphing those. If you can get the asymptotes in the center, you can pretty much draw your graph of the hyperbola. Okay. And as we can see on our graph, the length of the transverse axis, so from vertex to vertex, it is a distance of 8, which is what we would expect. So that's kind of another way you can check it a little bit. And you can always graph it on a calculator to check as well, if you were asked to graph something by hand. Any questions? Any that we want to go back to there? They're about halfway between y equals 4. Oh, okay, for the foci? Awesome. Yeah, that sounds about right. Thanks, Aiden. Yeah, if you want to estimate where the foci are, you definitely can. And so that would put it, if this is like 5 and this is negative 5, then that would put our foci right about there, about halfway between. But again, it's really hard to tell on our teeny tiny graph. So if you wanted to like graph it a little bit bigger, blow things up a little bit, it'd be easier to see. Anyway, that's pretty much everything we need to be able to do for today and for today's assignment. So let's take a look at today's assignment. I'm going to post it and we'll take a look together. And then if you would like to stick around and do another example, you can. If you want to get going and do it on your own, you can. So today's assignment, in addition to finishing the Desmos activity if you didn't finish, is one IXL, and it's finding properties of a hyperbola, either from the graph or from the equation. So they'll ask questions like, what is the center? Looking at the picture, and we notice, oh, this one is 0, 0. We didn't talk about the conjugate axis. Well, I suppose we could do that real quick. You kind of talked about it in your Desmos activity. So remember when you guys were making that rectangle? Let me see if I can pull it up real quick. Where did it go? Oh, it was on here. No, here. Okay, so the conjugate axis is that distance between D and E. Why isn't it actually making lines? Oh, that's fun. Sorry, having fun with the line tool. All right. So when you guys were making that rectangle here, and you had those points D and E, and notice that they were related to the number under the or the B value. The length of that conjugate axis is 2b, and you can tell by grabbing like if back to the IXL, by grabbing points like if you go to the vertex and go up until you hit a point on your asymptote. So like if I start here and go up and we hit this point, it's 3 away. And I go over to being across from the center. This point here would be one of like my D or my E value that we saw on our hyperbola thing here. So this one is a distance of 3 from the center. So 2 times that would be the length of the conjugate axis. So the length of the conjugate axis here would be 6. Or it'll ask what are the vertices. So we pick those numbers out like 6, 0, and 0, 6, 0, and negative 6, 0. Or it'll ask what's the length of the transverse axis, the one that we're more used to finding. And in this case, it's also 6. Okay. And then it'll ask you for things like the asymptotes as well, which we've learned to find. And you can also find them just like you did on your hyperbola Desmos activity by pulling points, or you can do it by finding A and B and then using the center and A and B. Anyway, that's the assignment. If you would like to do more examples with me, feel free to stick around and we can do as many as you like. If you prefer to go and start working on your own, you are free to go. If you run into trouble, I will be here probably in this Google Meet for the next 10 minutes or so. Otherwise, have a wonderful day.